Hi there, welcome to another video. Right now, let's just talk a bit about the product rule. Okay, so the product rule is a rule that we're going to use when we want to differentiate two functions, we'll call them u and v, that are multiplying into each other. Okay, so when we first learned about derivatives, we knew that if we were taking, let's say, the derivative with respect to x of 2x plus 3, we could split this into two different expressions, right? We could say d by dx 2x plus d by dx of 3, right? And we can only do that because there's a plus between the two functions 2x and 3. So if there's a plus or minus between them, we can split it up into the derivative of the first thing plus the derivative of the second thing. However, when we're multiplying two functions, it doesn't quite work like that. We can't just say that the derivative of a function times another function equals the derivative of the first function times the derivative of the second one. It doesn't work like that. So this rule is saying if we have two functions, u and v, that are multiplying together, the derivative of that product is going to be the function u itself times the derivative of v with respect to x, or whatever your variable is, plus v itself times the derivative of u with respect to x, or whatever variable you're dealing with. Okay, so a bit of an easier notation I have here, u and v are our functions. Okay, so u times v prime plus v times u prime. So it's just kind of swapping out the u's and the v's, getting both combinations, and we're adding those two products together. Okay, so let's go ahead and do an example. Okay, so let's say we wanted to differentiate. I want to find the derivative with respect to x. Let's say our function was 3x sine x. Okay, well, let's call this 3x our u. Okay, and let's call this sine x our v. Okay, so the product rule says that if we have two functions u and v multiplying together, which we do, 3x and sine x, the derivative, d by dx, of u times v, 3x times sine x, equals u times v prime plus v times u prime. Okay, so what's our u going to be for this part right here? Well, u is just 3x. We assigned 3x to u, okay? And we have to multiply that by v prime. V prime is just the derivative of sine x. The derivative of sine x is cos x. Okay, so this first term here is done. It's 3x cos x. Now we're going to be adding v, right? V times u prime. Well, what's our v? Our v is sine x, so it's going to be plus sine x. Okay, and what's u prime? Well, u is 3x. So using our power rule, we know that's just going to be 3. Okay, so our answer is just going to be 3x cos x plus 3 sine x. That would be our answer, and we could always, factor out that 3. So it would be 3 times x cos x plus sine x. That would be your solution there. Okay, so hopefully that makes sense. Let's just move into a different example here. Let's say we're taking the derivative with respect to x. Instead of going d by dx, I'll use a different notation. I'll go, let's say we have 6x minus 5x cubed. Okay, that's multiplying into 2x plus 1. Okay, and let's say we're taking the derivative of this whole thing. So 6x minus 5x cubed times 2x plus 1 prime. So notice how this prime, this kind of apostrophe is on the outside of all of it. So we're taking the derivative of these two products. Okay, so let's assign our u and our v. So I'll call this first one u, and I'll call this first one v. So even though there's two terms in this u, where in the first example we did there was only one, that's okay because we're gonna have to take the derivative of u to use a product rule, but the derivative of u is super easy because there's a minus between the two terms. So as long as they're not multiplying or dividing together, we can have two terms like this in one of our assigned variables u and v. Okay. So remember our formula was u plus v prime. That's going to equal uv prime plus vu prime. Okay, so if our u is, I'll move this over a bit. So if our u is 6x minus 5x cubed, right? I'm just going to rewrite that. 6x minus 5x cubed. And we're going to multiply all of that by v prime. Okay, so we know v is 2x plus 1. The derivative of v is just the derivative of 2x plus the derivative of 1. Okay, well the derivative of 1 is just 0 because 1 is a constant, it's not changing, so its rate of change is 0. And 2x using our power rule is just going to be 2. So our v prime term is just going to be 2. So this is going to be times 2. So this part right here is done. Now we're going to be adding v. V is 2x plus 1 times u prime. Well, our u is 6x minus 5x cubed. Okay, so we take the derivative of 6x, which is 6. Okay, and we're subtracting the derivative of 5x cubed, which is just 15x squared, using our power rule there. Okay, so now let's just expand this a bit. Let's go 12x minus 5x cubed, or minus 10x cubed rather. And remember, we're adding, we gotta do a bit of expanding here. 2x times 6 is positive 12x. 2x times negative 15x squared is negative 30x cubed. 1 times 6 is plus 6. 1 times negative 15x squared is just negative 15x squared. So let's combine like terms here. 12x plus 12x, that's 24x. Negative 10x cubed, negative 30x cubed, that's going to be negative 43x cubed. Okay, we got negative 15x squared is the only x squared term, so we're going to leave that as it is. And we got this plus 6 hanging on there. So this is going to be your solution for our derivative. Okay. And you can see the highest degree in our u term was 3. And that highest degree multiplied by the highest degree in v, which was just 1. Adding these exponents 3 and 1 together, we'd get 4. And from our power rule, we know that the derivative of something to the power of 4 is going to be that thing to the power of 3. So that's why our highest degree in our derivative solution is 3. Okay, maybe you noticed that there. Let's just do one more example here. And also for this question, if you wanted to expand the 6x into the 2x and the 1, do all of your expanding first, you could do that and you would get the exact same answer that we did, or that we got, without using the product rule. So if you took the product of these two polynomials and you multiplied them, expanded them out first, and then differentiated with the basic differentiation rules you already knew, you'd get the same answer, except this way is much quicker because notice how it's already factored into two products. So if we have two products that are polynomials, and we're taking the derivative of those two products, the product rule makes it really easy. So we just arrived at this answer way quicker. Okay, so our last question, let's call this let's call this f of t. Okay, that's going to equal 3x cosine x, okay, minus x to the fourth tan x. Okay, so first let's look at what's going on here. We have two things multiplying into each other here, a product of two different terms, 3x and cos x. And when we're finding the difference, right, we're subtracting x to the fourth times tan x. So essentially, we're going to have to use the product rule twice here, right? Because we have the product of 3x times cos x. If we want to take the derivative of this whole thing, right, we're finding f prime of t. If we're taking the derivative of this entire thing, that means we're going to have to find the derivative of 3x times cos x, and we're going to have to subtract the derivative of x to the fourth times tan x from that. All right, so if we call this our u, 3x, and this our u, x to the fourth, and we call this cosine x our v, and this tan x our v, we can focus on two parts of the equation at once. Okay, so right now let's just focus on the left side. Let's find the derivative of 3x times cos x. Okay, so the derivative of 3x times cos x, right, equal minus. Okay, so right now we're finding the derivative. I'm going to plop it in there. Derivative of 3x times cos x, that's going to be 3x times the derivative of cos x, so that's going to be negative sine x, so that's going to be negative 3x sine x. And remember, we're adding v times the derivative of u, so that's going to be 3 cos x. Okay, so we found the derivative of 3x cos x, and remember, we're finding the derivative of the difference between these two functions. So we found the derivative of the first part, now we're going to subtract the derivative of the second part. Okay, so our u is x to the fourth, so it's going to be x to the fourth times the derivative of v, which is tan x. Derivative of tan x is secant squared. So it's going to be x to the fourth secant squared x plus v times the derivative of u. So v is tan x, the derivative of u is 4x to the 3. So it's going to be plus 4x to the 3, gotta write small here, tan x. Okay. And if we wanted to get rid of these kind of ugly brackets, we'd get negative 3x sine x plus 3 cos x. And then we're just expanding, we're distributing this negative in there, so negative x to the fourth secant squared x, not plus, minus 4x cubed tan x. So this is going to be your derivative, your solution for that question there. And honestly, the product rule doesn't get too much harder. You just have to be able to recognize what's going on in the question. So this last one was probably the hardest because we were finding the difference between two products, and we had to differentiate that whole thing. So we just had to break it down into two different differential expressions. So we had to find the derivative of 3x cos x, and then subtract the derivative of x to the fourth tan x. And the subtracting part isn't new to us. That's not the issue because we can find d by dx of this function minus d by dx of this function. That's going to be all good. The new part was using the product rule to find each respective derivative. Okay, so I hope this video helped you with your questions and concerns regarding the product rule. My next video, I'm going to be talking about the quotient rule, so stay tuned.